So today we're going over chapter 9, section 7. We're going over the law of sines and the law of cosines. So this is one of our core concepts, the area of a triangle. You guys are probably used to the area of a triangle being the area equals 1/2 the base times the height. But that is not always the case. If you don't have all the information of the base and the height, you can't really get the area. But there's different ways of doing it. So we have this area of a triangle. This is where the laws for sine and cosine come in. The area of a triangle is given by 1/2 the product of the length of two sides times the sine of their included angle. For ABC shown, there are 3 ways to calculate the area. So in this case, let's say we're doing it based on angle A. We would do the area based on side B and side C, all of that multiplied by 1/2 and the sine of A. If we were to do it based on angle C, we would use B and A as the sides, again, all of them halved. And if it were B, I would use C and A, again, all of them halved. But the key part is that it's the included angle. So you guys remember SAS, side angle side, it's still the same idea. To find the area of a triangle, you will use the sine of that angle times both sides. Key part is the angle has to be in between the two sides. So like I said, for B, CA, for C is B and A, and for A is C and B. It's always going to be that case, and you should be plenty fine to be able to do this to get the area if you're only given two sides and one angle. So we have example 1. They want us to find the area of the triangle and round the answers to the nearest tenth. So they gave us side BA and side AC, and they gave us the included angle of 135. So following the information from the last slide, the formula for the area would be 1/2. In this case would be side BA times side AC and the sine of 135. So if we plug that in, we're going to have the area equals 1/2. BA is 19. AC is 17. And then we're going to just write sine of 135. Now I'm going to put that in my calculator. Sine 135 times 17 times 19. All of that halved or divided by 2. And we get that the area of this triangle is 114.19. But again, they wanted it to the nearest tenth. So our area is going to be 114.2 units squared. That is a good point. Whenever it's an area, it's always going to be area is always units squared. The unit may change. It may be feet, meter, whatever the unit yards that we're using, but it's always going to be squared. All right, now we have the law of sines. The law of sines is theorem 9.9. So theorem 9.9, law of sines, it states, the law of sines can be written in either of the following forms for triangle ABC with sides of length A, B, and C. So this is always going to be sine equals the third sine over the lengths. The key important part. All right. So the key part here, guys, you can write the sine on the top or on the bottom. It's the same. It wouldn't matter. The key part here is that if you put sine A, you have to put length A. Sine B, length B, sine C, length C. And same for here. It's always going to be a proportion, and they're always going to match the side to the angle. That is the key part for this rule. So now we have example 2, SSA case. So solve the triangle and round the decimal answer to the nearest tenth. So how do we find the triangle? Well, this is not a 90-degree triangle, so we can't really solve for the sides or the angles by doing the Pythagorean theorem or just adding or subtracting by 90. So we're going to have to use the law of sines and the law of cosines. Now, let's start off by doing the law of sines. So if we have sine 51 over 18, So you guys see these are across from each other. So this is going to be side A, side C, and side B. I can say that equals 17, which is side C, of sine C. Now, this is a proportion, guys, so we can actually go ahead and cross multiply, and I'll get 17 sine 51 equals 18 sine C. I'll divide both sides by 18 to give me that 17 sine 51 over 18 is equal to sine C. Now remember, we're solving for the angle, so this whole thing is actually going to be the inverse sine. I'm just going to put a little arrow. That's going to give us our angle C. So when I do that, I get sine 51 on my calculator. I multiply that by 17, and I divide it by 18. Now my angle is going to be the inverse of that. So my angle C is going to be 47.2 right here. So angle C, 47.2. We also need to find angle B, and we need to find side B. Now for angle B, since I just found angle C, I can do 51 plus 47.2 plus angle B equals 180, because all triangles add up to 180. So I can do 47.2 plus 51, subtract that from 180, and we get that angle B is actually 81.8. Now, all we're missing is the length of B. We need to find the angle in order to solve for it. So I'm going to go ahead and use the law of sines again. So let's say sine of B over B, but we already found the angle. So I'm going to change that angle to 81.8 equals, I'm going to actually use sine 51 again because that's what's given, over 18. I'm going to go ahead and cross multiply, and that's going to give me 18 sine 81.8 equals B sine 51. So we get that B is going to equal 18 sine 81.8 divided by sine 51. So when I plug that in onto the calculator, I will get that my side B is 22.9. So we found side B, 22.9. We found both angles, and we are done. We have all three angles on all three sides, so that is how you would solve for this triangle in particular. For example 3, they want us to solve the triangle and round to the decimal to the nearest tenth. Now, because again, I'm going to have to use the law of sines because this is not a 90-degree triangle. Guys, law of sines and cosines, I forgot to mention earlier, it's used a lot for triangles that are not 90 degrees. So I'm going to go ahead and label this as side C, side A, and obviously we know side B is included right there. Now, the first thing I'm going to do is actually I need to find angle C, I need to find side C, and I need to find side A. So, to find angle C, sorry, I'm just going to go ahead and do angle C plus 85 plus 29 equals 180. And when I put that into the calculator, I get that angle C is 66 degrees. So we already filled in one information. Now I will use the law of sines to solve for the rest of the sides. Again, I cannot use the Pythagorean theorem because this is not a 90-degree triangle. So I'm going to go ahead and do sine 85 over 9 equals, I'm going to start with sine 29 over side A. Again, you can cross multiply and get A sine 85 equals 9 sine 29, and then I get a to equal 9 sine 29 over sine 85. And when I plug that into my calculator, I get that my side is 4.4, again to the nearest tenth. So that's A, 4.4. Now to find side C, I'm going to actually use the same sine 85 over 9 because that's the only thing that's given. So I always prefer to do that. Makes it less likely to make a mistake. So sine 85 over 9 equals sine 66, so the angle we found, over C. Again, cross multiply, C sine 85 equals 9 sine 66. I'm going to divide and I'm going to get 9 sine 66 over sine 85. So I'm going to go ahead and plug that into my calculator. And I'm going to get that it's going to be side C is 8.3 when rounded. So we found the angle that we had missing and we found both sides. All right, so for example 4, we have a different case. So I want us to solve a triangle and round the decimal answers to the nearest tenth. All right, so we have, again, to find angle A, we can do angle A plus 81 plus 70, all of that equals to 180. And then I'm going to put it in the calculator, and I get that angle A is 29 degrees. Now, I already found angle A. This is side B and side C. We're still missing side B, and we're still missing side C. Now, because we don't have anything to be able to do sines, we have to use it based on the angle that we found. So, I can do sine 29 over 10 equals sine 70 over B. Now, I'm going to go ahead and cross multiply to get B sine 29 equals 10 sine 70, and that's going to give me that B equals 10 sine 70 over sine 29. Now I'm going to plug that into the calculator, and I'm going to end up with, so we get for side B 19.4. Now we're going to go ahead and solve for side C. So I'm going to set it up again as sine 29 over 10 equals sine 81 over C. So I'm going to go ahead and cross multiply. C sine 29 equals 10 sine 81. And C equals 10 sine 81 over sine 29. All right, when I plug that into the calculator, I get that C is 20.4. So now we found all of the parts for this triangle. So now we have the law of cosines. We just learned law of sines, so now we're going to do law of cosines. Law of cosine states, if triangle ABC has sides of length AB and C as shown, then the following are true. So if you're solving for one of the angles, you can solve for anything with this setup as well. If you have sides AB and C, you can solve for the angles. If you put it equal to angle A, then it will be the addition of the other two sides minus 2 times the multiplication of those sides, cosine of the opposite. That's true for all of them. So if you start with side B, we're going to end up with cosine B at the end. And if you do it with side C, we're going to end up with cosine C at the end. Again, the middle part, we add the squared of the other two sides, and we subtract 2 times the multiplication of those sides. So here we have example 5. They want us to solve for the triangle and write decimal answers to the nearest tenth. So again, this is side A. This is, again, angle B and C. So we have to find angle B, and we have to find angle C and side A. Now I'm going to start by solving for side A with the law of cosine. So A squared equals B squared plus C squared minus 2BC cosine of A. So when I do that, I'm going to plug in the numbers. A squared, remember this is B and this is C, equals B squared, so 23 squared plus 26 squared minus 2 times 23 times 26 cosine 114. Now I'm going to go ahead and start putting that into the calculator. So I get 23 squared. That's going to be 529 plus 26 squared. That is 676 minus this remainder thing. Now that's going to be A squared. So 529 plus 676 is 1205 minus 2 times 23 times 26 is 1196, and then times cosine 114. I'm going to multiply that times cosine 114, and I'm going to get A squared is equal to, let me do 1205 minus 1196 cosine 114, and that's going to give me 1691.5. And then I'm going to take the square root, and that's going to round to side A being 41.1. Now, knowing that, you can either do rule of sines or rule of cosines. I'm going to stick with one more rule of cosines just so you guys have practice with it. Let's solve for angle B. So, if we do again, if we're solving for angle B, we need to start with B squared. So I'm going to write it here in different color. B squared equals A squared plus C squared minus 2AC cosine B. Now, I'm using the law of cosine, guys, just to have more practice with it. At this point, you have one side and one angle, so you're able to use the sine rule if it's easier. So, B squared is 23 squared. Then A squared is what we just found, 41.1 squared plus 26 squared minus 2 times, I'm going to keep writing it down here, A 41.1 times C, which is 26, cosine B. Now I'm going to go ahead and do 23 squared. That's going to be 529 equals 41.1 squared. That's going to be 689.21 plus 26 squared. That's going to be 676 minus 2 times 41.1 times 26. We're going to get 2137.2 cosine B. Now I'm going to go ahead and combine everything to the left side. So we're going to get 529 minus 1689.21 minus 676. And then that's going to be negative 1836.21 equals negative 2137.2. I'm going to go ahead and divide. So I'm going to be, cosine B. So I'm going to divide. I'm going to get negative 1836.21 divided by negative 2137.2. That's going to equal cosine B. Now I'm going to put it into the inverse function, so cosine negative 1 of this whole thing. So when I do that, I get, I'm plugging it into the calculator as we speak. I get that my angle B is 30.8. Now, since I found angle B and I have angle A, I'm just going to go ahead and do 114 plus 30.8 plus angle C equals 180. So if I do 114 plus 30.8, subtract it from 180, I get that angle C is 35.2. Again, you could have done it many different ways. I just did cosine again to make sure that you guys understand it. Here they want us to solve the triangle and run to the answer to the nearest tenth. So I'm going to start using the cosine rule because honestly that is the only thing I can use right now. So we're going to do A, B, C. We're going to do the A squared equals B squared plus C squared. It won't let me write the square for the B, but the B is also square. Minus 2BC cosine A. So I'm going to get 4 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cosine A. So I'm going to go ahead, guys, and just plug it into the calculator. And I'm left with negative 45 equals negative 60 cosine A. So when I do the inverse cosine of negative 45 divided by negative 60, I get that my angle A is 41.4. Now I'm going to do the same thing for angle B. So we get B squared equals A squared plus C squared minus 2AC cosine B. B squared is 6 squared, 4 squared, 5 squared, minus 2 times 4 times 5 cosine B. So I'm going to plug that into the calculator. And I'm going to get negative 5 is equal to negative 40 cosine B. And when I plug that into my calculator, I get angle B to equal 82.8. And then to find the last angle, I'm going to do 82.8 plus 41.4 plus angle C equals 180. When I plug that into the calculator, I get that angle C is 55.8. Here we finish solving the angle, so we have the entire triangle. You guys do have homework tonight. So if you don't have any questions, that's it for today. Have a good rest of your day.